Hello, friends. It's me, Rasa. Again, if you haven't looked at my previous two tutorials on simultaneous equations and quadratic equations, please look at my previous YouTubes on News Rasa, and also subscribe if you haven't subscribed already, and share with your friends. Obviously, these tutorials are going to come in on a regular basis. I will cover, the method properly so that you can benefit, and also you can share with the others who can benefit too. So therefore, if you haven't subscribed already, please subscribe and tune into my YouTube channel. So today is another important topic. I know that by looking at the topic, you might think, oh yes, this is going to be interesting, isn't it? Right, yes it is, because most of the students they find straight lines challenging, and so I'm going to look at today how to make it easy for you so that you can look at the method and then face any type of questions with confidence. That's the important thing, because you don't need to be reluctant to approach these questions at all, because these are very straightforward. So let's crack on with our today's topic is straight line, and I would like to start with the standard equation of a straight line. So I'm sure you may have come across with it before, so if you have not, this is not a surprise for you, but we have to start from somewhere. So if I look at the standard equation of a straight line, it's going to be y equals mx plus c. Okay, right. So that's the standard equation of a straight line. So the reason I call it as a standard equation, because if you look at this straight line equation, most of them, you can just bring it into this format. Okay, so what does this m and c stand for? I'm sure you're already aware of y and x, right? They're basically the y-axis and the x-axis, but you may not know about the m and c. So we can define the m and c. So m is basically the gradient, right? Or sometimes they call it as a slope, right? Or rate of change. Okay, so there are different terminologies, but in this particular topic we will call it as gradient, right? So m is for gradient, and then the c is the y-axis intercept. All right, so y-axis intercept means where the straight line is basically crossing the y-axis, the perpendicular axis. So this is where the c is going to be found. All right, so say for example, if I have a straight line like that, and this is my x-axis and that is my y-axis. So if I have a straight line going through there, and you can see here, right, that's my x-axis, the y-axis crossing point, isn't it? So that's the point, and that's what called the c. All right, so I'm going to start defining the m and c like this. All right, so at the moment I hope you're with me so far, right? So the main thing is what? The standard equation of a straight line, and you do have the gradient, which is the m here, and then the y-axis intercept. So as long as you know this basic, then we're going to look at each of them to see, okay, how we can find the gradient, which is the m, isn't it, right? And then also we can use some, again, formal methods to answer these questions, right? Yeah. Okay, then, right. So I'm going to now look at defining 2 points first, because when it comes to a straight line, so we will start with 2 points. So they're going to be like x1 comma y1, and the other one is going to be like x2 y2. So it's important that you do define the coordinates. Okay, so the x coordinate, the first point has x coordinate x1 and the second point has x coordinate x2. So similarly, y1 and y2. So the first one is always the x coordinate, and comma, the second one is the y coordinate. So I hope this definition is quite useful. So then how do we define the gradient, which is m, isn't it, right? So I'm going to define the m as, say, m equals the y difference. Okay, so why do we call it as a y difference? I will draw the graph and then show you in a moment. All right, divided by the x difference. Okay, Okay, in different way, it is also done as say the y2 minus y1 over x2 minus x1. Okay, so that's the definition, for the gradient, right? So where is this coming from? When we say slope, okay, so if you have a straight line like this, right, and you have the x here and the y here, right? So your straight line may be going through like this, all right? So let's get a point here and a point there, right? So if we want to name this point as say P1 and that as say P2, right? So how do we define the P1 and P2? So P1 is that one, and then P2 is this, right? So we define them as two different points, okay? And they are two different points on the same straight line, okay? Right, so then we're going to make a right angle triangle like this, right? So the height, the y difference, yeah? Why we call it as y difference? Because the y coordinate here is y1 and the y coordinate there on the point 2P is y2. So that's basically here, isn't it? Yeah, y1, y2. Okay, so we're going to have this difference as y2 minus y1. So similarly, we can define this, the horizontal length, as x2 minus x1. So now, when it comes to the gradient of this line, then we simply do, okay, say y2 minus y1 over x2 minus x1. So happy with that? Right. Okay, so I hope you're with me so far, right? So that's the definition of what? The gradient, okay, the slope. All right, so this is the important one, right? So the next point, I'm going to talk about is, okay, how to put this into an example. I think that would make it, easy for you, right? So then you just need to apply the gradient formula only, right? Yeah. So I will leave the gradient formula there, all right? I will look at only the two different points, okay? So I'm going to write down the 2 points, okay? So let's say you have 2, 3, right? And say 5, 6. All right, fair enough. Yeah, so it's 2 points. So how do you work out the gradient of the straight line going through these 2 points? Okay, that's the question. So here we have our y2 and this is our x2. This is our x1 and that is our y1, right? Okay, so what do we have to put? We have to say y2 minus y1 over x2 minus x1. You with me? Right. So what is the y2 here? Is 6. And what is the y1? Is 3. Right. So what is the x2? Is 5. And what is the x1? Is 2. Right. Okay, so you simply do the substitution, right? Okay, this is at the GCSE level, right? Okay, so, but you might have already learned about, the substitution, right? So what I'm doing is I'm just substituting the values for y2, y1, x2, x1, right? So what is 6 minus 3? Yes, you know it, right? Okay, so it's 3. And then what is 5 minus 2 is 3, right? Okay, so your gradient, of the line going through these 2 points is basically equal to 1. So now if you remember, okay, so can you remember now, can you recall the equation, the standard equation of a straight line I mentioned at the beginning of this video? Do you remember it? Can you try to think about it, right? Because it's important that you recall those things, right? So I will write it for you again, all right? So what is it? Y equals mx plus c. So basically, we are working out the m first. Okay, so I hope you understood, how to work out the m using the formal method, right? So the method is quite important because then the questions, may be different, right? So instead of 2, 3, they might give you like minus 2, minus 3, in the next one. The only thing you're going to do is basically what? Change change the values, that's it. But apply the same formula, right? So this is great way of learning, using proper methods. Because then, when you are to face the exam or the test or whatever, you will be fine because you remember the method and you can just do it, Okay, so right. So what we're going to do now is, okay, so we worked out the gradient m as 1, right? Okay, so now I've got the gradient as 1. So what do I write down the equation as? So I'm going to do as, say, 1x plus c. Why is it 1x plus c? Because I'm just substituting the value, of the gradient m as 1, into the equation y equals mx plus c, right? Okay, so you're with me so far, right? That's great, all right? So let's go to the next step. Okay, now we worked out the gradient and substituted into the equation, all right? So we've got y equals 1x plus c, okay, good. So the next step, obviously, to find out the c, isn't it? Right. So how do you work out the c, right? So I'm going to use a different color, just to make it more attractive for you. All right. So here I'm going to do, I'm going to select, one of the points, okay, either P1 or P2. So here we have, say we can call it as a P1 and this one as, say P2, right? So how do I, whichever the point, okay, it doesn't matter. I can just substitute any of those points into this equation and, we will get the final equation of a straight line, right? Okay, so straight, you're looking forward to getting the first, equation, right, using the proper method, right? So I'm going to put, say P1, right, which is 2, 3, right? So it's 2, 3. So I'm going to put that into this equation. So if I put that into the equation, what do I get? So this is my x and this is my y. Okay, so I've already got m, found out, right? So I'm going to put y as 3, okay, equals, and then the 1 is the gradient already there. And then in place of x, I'm going to substitute what? It's going to be 2 because the x value here is 2 for P1, okay? Point 1, the x value is 2, y value is 3. So I'm just substituting, 2 and 3 into this equation. Okay, are you happy with that? Good. Right, and then what am I going to get, is a c. So c is the one I need to find out, right? Okay, so I've got my c here. So my equation would look like what? 1 times 2 is what? Is 2, yes. Okay, so it's 3 equals 2 plus 3. Okay, are you happy with that? Right, and then I just need to find the c from here. So I just need to do a rearrangement. So I have to bring, the 2 to the other side. So I will write down something like this. So c equals 3 minus 2, which equals 1. Okay, so we have now worked out the y-axis intercept as well, right? Using one of the points. All right, so that's interesting, isn't it? Right. So I'm going to select, I'm now going to be able to write down, the final equation of the straight line. So what is it going to be? Y equals 1x plus 1. And that is my final equation of a straight line going through these 2 points. Okay. So I hope you found this, useful so far, right? So what did I do? I worked out, the gradient first, and then I substituted, one of the points, to work out the y-axis intercept, which is c in this case. The gradient was m, and the y-axis intercept is c. So once I got the y-axis intercept, so m equals 1 and c is equal to 1, then I substitute it into the standard equation, which is y equals mx plus c, to get my final equation. So is that clear? Right? So this is just an introduction of, straight line. Okay. So if you found this, quite useful, and, you're okay with the method, and, you do understand this, right? So I'm planning to do more examples and then go to the next levels, by doing, more and more subtopics, within straight line. So, if you like it, please comment, and, please subscribe, and share it with your friends and families, okay, so that they can benefit as well, because these are quite useful methods, like using proper methods. And I hope this will also help me to generate more videos like this in future, so that you can benefit. I know these are all hard times because of COVID, so we are actually using the virtual platform to learn as much as we can. And also it's free, of course. So if you have any questions, you can post on the comments box, or you can just send a message to my mobile number, which is on the flyer, and I can try to help you as much as I can. But otherwise, thanks for watching, and you can definitely do maths, so please keep tuned into my YouTube channel, News Rasa, and I will do my best to help you, and you can reach real good heights. So yeah, good luck, and stay safe. I will see you in the next video. So take care. Bye bye.